Hello guys, good morning guys. Welcome to another episode of Sound Talk Show. We are going to code Wolfram Language today. Wolfram Language, we are going to write a function that exports Wolfram Language two-dimensional graphics into SVG. So two-dimensional graphics, that's fantastic. Let's try one of them, okay? So this is gonna be kind of boring and dry for you guys because I'm just gonna code very technical. If you have questions for me, you can ask me. So this is Wolfram Language. We just evaluated this code and it generates that. So that's 2D graphics. Now I want to export it. So let's see. Okay, so let's export this one, okay? It has a built-in function to export graphics. So for example, export, and then so let me magnify so you can see. So here's a code, okay? That's run it, so it's great. So actually I don't want this, so let's modify this. Okay, so we're gonna write a function to export SVG graphics. So let's see, so let's, I'm just gonna start working on it. Start a Wolfram code, paste it, pop into a new window. I'm using Xafly keys, and I'm using Emacs. So Xafly keys is a package in Emacs that allows the most efficient key binding. So you can search on the web, Xafly keys, you'll find it. It's on GitHub. There's lots of videos. If you are watching this offline, play at 1.5 speed minimum, okay? So I'm using Xafly keys, and the pink window shows all my command calls and the names as I type them. So close, for example, close, you can see close current buffer. Can you see it? Yes. So close that, and here I'm using Wolfram mod, so you can see there it is, Wolfram mod. You can get it, it's free on the web. So to go to the website, you search for it, you'll find it, Wolfram mode. This allows you to code Wolfram language in Emacs. And Wolfram language you can download for free. Just search for xali.info Wolfram language tutorial. You can download it for free. It's the most powerful, most advanced programming language than all others by a magnitude. Okay, so you can download it. You can watch my over 100 videos on Wolfram language in the past on YouTube. Okay, so Wolfram mode. So let's close that. So let me modify something here. Again, we're gonna write a export to SVG. So, but first of all, let me show get this to work. So graphics grid. I don't want graphics grid. Okay, so let's just say that. Okay, so that's two graphics. Okay, so copy all, go back here, select all, paste. So that's one of the graphics. This is the second graphics. Now let's export it. So let's export. Okay, so export, what's the syntax? And okay, so the first argument is gonna be a file name. So xx.svg, let's just say that. Let's say xxy, okay? Then, okay, select all. Select all graphics. So let's look up the documentation for graphics. That's what we want. Let's turn on JavaScript. It's already on. Magnify. Okay, so copy the whole, go select all, paste, run it. Okay, fantastic. Now you can see it's exported xxy.svg. That's in the document folder. So go to document xxy. There it is. Open it. There it is. open it. So SVG is a XML file. So let's switch to XAR HTML mod. So here is the source code for the SVG. So you can see lots of these repetition lines. So this file is 56 kilobytes. It could actually be smaller, just all these, there's maybe 50 lines or 100 lines. It should be just, 5 kilobytes. So the generated SVG is like 10 times larger than necessary. That is why I want to write my own customized export to SVG command. Because if you look at SVG, so if you don't know SVG, let's look up. So I have a tutorial on xarli.info. Just search for it. If you are here, say hi, okay? Let's see. Hello, simple postman. So let's pop this out. If you are watching this offline, play 1.5 speed. And if you are watching here, say hi. If you have questions about Wolfram Language, ask me, okay? So here's a SVG tutorial. SVG is just XML, okay? So it's just like HTML. So, you paste that, then you get a line. So because there is a line primitive, you can see. Okay, so let's magnify the browser more. So it's larger, it's always easier to see. So 150 is kind of too large. But anyway, so here's a line, and here's a rectangle by the primitive rectangle, and here's a circle by the primitive circle. And a line is very simple. You can see it's just the XY coordinates, the beginning position and end position. Okay, but what Wolfram Language generates is that it uses path. I mean, you see, it repeats this style, for every line. You shouldn't need to. You can put all these styles, like all the repetitions, so on and on, into one place. Can I do it? Yeah, actually, I can do it. Let me show you. Okay, so all these styles. So first of all, go to the directory, make a backup. So in case we made a mistake, now go back here. Now copy this line. Let's modify it, and let's make it multi-line so I can see it. So you see all these repetitions. Okay, so the whole style can be, make it one line. Okay, cut it, can be placed here. Okay, then this path, I don't need it. Okay, so that should do. So now we just delete all these styles. So let's, oh god, copy, find, replace that by empty. So replace, shift ban, so replace them all. Okay, so you can see, and now save. Okay, now go to directory, refresh. Now you see we already saved half of the file size. Fantastic. So you see, the problem is just that when you use Wolfram language to export to SVG, the result is not too efficient. However, we have another command. So let me do it again. Okay, so let's say refresh, edit. So let's say this is original. Okay, then this is A. Okay, rename them. So here's original, and here is the one we modified. So now let's make a backup of the original, and let's name, replace a space by underscore. Now I want to call a SVG optimize. Let's see how much it can save. So there's a command. We did a live stream about a week or two ago. So SVG optimize. There it is. Okay, tab V. So do it. Done. Okay, refresh. Okay, so it also saved, you see, it also saved half of the files, file size. So let's put it to HTML mod so we can see the code, and let's just, okay. So let's make it multiple lines, okay. Okay, go to the top. Okay, so you can see it did something similar like what we did. Okay. Yeah. Why is this? Okay. Yeah, it did something similar, but anyway, this is still inefficient. Okay, because you can see here the stroke is repeated all over. So that's why we want to write, oops, we saved the original. Okay, that's why we want to write our own export to SVG. So let's get started. So this is gonna be, extremely technical, because so most of you won't understand. I'll explain along the way, but it's gonna be difficult, because unless you have programmed Wolfram language for a year, my explanation wouldn't help much. So you're gonna basically just watch me code, okay? So that's the reason, that's the whole setup about why you want to write export to SVG. So here is a sample code. So let's put it back. Syntax correct, showing browser. So that's what we talked about, code. Okay, so let me see the question. Have you ever thought about creating procedural geometric art for sale? It seems that you are a huge lover of such things, according to your blog. Yes, for sale, you're not gonna sell anything. The artworks, especially, there's lots of artists, you're not gonna make money unless you are one in a million or 1 in 100 million artists. Then maybe you become extremely famous. Then 1 in a million, very rare. Especially if you are doing mathematical art, like the geometry, there's no money for it. So mostly, I love this subject, visualization of geometry, but this is mostly for, for the beauty of it, and also for like illustration for mathematics and educational purposes. Now, let's digress a little bit. If you don't know, of course, there's MC Escher, one of the most famous for creating mathematical art. So, for example, that's Escher's work. Of course, he's not rich, he's pretty poor. He became famous, like, I think after he died, he became more and more famous. So anyway, or his most of his works is math oriented. For example, this one of my favorite, this one shows the perspective, okay, perspectivity. So you distill, so for example, this one, beautiful, you distill the mathematical aspect of it, then what you get is this, okay. And you can distill this further by just showing, this is already pretty much distilled. So because you only see lines and square, you only see lines. So that you see this image is the essence of the mathematical essence of this, but this one is more attractive to to average person, because it got these fantastic creatures. But the mathematical essence is like this. And you can generate this, so it's very, so I'm very interested in this. You can generate this using Wolfram language. Okay, so I've done quite a lot related things like that. Okay, so here is another Escher's artwork. This one is named Chameleon, I think. Again, it's mathematical because it shows the regular. This is called uniform polyhedra, I believe. And then someone built it in Second Life, which is like a virtual reality, a friend. So this is in Second Life in 3-dimensional. So you can walk around. You can in Second Life you can walk around as a fly, like you can view the whole thing like you are inside the building. And she she also built other things. It's on YouTube. You can watch. Just search for Xali math blog on xali.info. You'll find this. Okay, so I'm into this. So that's Escher, and that's another Escher, and that's another Escher. Okay, so let's get back to this. Let's get back to this export. So this is gonna be very boring. You are not gonna see graphics because this is that's what I need to do today. Okay, so close that. So today's talk show. So what's the next thing? So so let's begin to write it. Okay, let's begin. Wolfram Language. Okay, so are we like ready? Yeah, good. Okay, so write a command to let's document first. Export 2D graphics to SVG. We want to do this because the built-in export function creates huge file size. Okay, let's begin. So the most simple one is let's do a circle centered on 0, 0 and radius 1. Okay, that's graphics. And to show that graphics, you just say graphics and that. Okay, let's say prim equals to prim stand for graphics primitive. Okay, and then graphics prim. Okay, then option axis. Okay, so you can see if we copy that, paste there. Oh, you got an extra comma, remove it. Shift enter to run it. So you can see we got a circle. Now we can export this. So we start to write a function. So let me so export. Let me show you. Okay, so export. If you export, copy that. So XX circle SVG. Okay, we can run this in here. Okay, run it. Is it done? Yes, I think so. Go to the directory, search for XX, search for circle, refresh, search for okay, not here. So where did it go? Oh, it's not done yet. Now it's done. Refresh there. Okay, so you open this file, then you switch to XML mode. So you can see, it generates this hugely, whenever you have a circle, it generates a very inefficient SVG representation because, it's trying to represent the circle by path. So the whole file, just one single weight. Actually, our circle actually also contains the axis, so that makes it more complex. But however, the circle itself is represented by path. You know, so the file size is 15 kilobytes, very inefficient. A circle could be simply just a SVG circle tag. Okay, so for example, let's go back to SVG basics, and you can see a circle is just that. Okay, let's try again. So close that. So this time, let's not include the axis, just circle. Okay, so run it. Okay, done. Now go to the directory, refresh, search for circle there. Now you see, now it's 869 bytes. Open it, circle, perfect. Now switch to XML mode. XML, okay? Now this one single long line. Now make it separate, okay? So you can see it represents a circle by using a path. So instead of a single circle like that, you know, just 50 characters, it represents a circle by a path. So you get this huge, you know, bunch of numbers. You know, those C, the C stand for, those are cubic, what they call cubic, let me show you. Okay, so path basics. So you go path, then you can go down. Those are cubic, what's the name? Bezier curve. Okay, so it represents a circle by using a cubic Bezier curve, which is kind of approximating a circle. So it's not very good. First of all, it blows up the file size. Then it's not actually 100% accurate because it's like approximating a circle. So I don't like this. But I was told by someone that in industry, actually all circles in the end are represented by, a lot of it is represented just by Bezier curve, I heard. But anyway, so I want to write a function so it export something like this. Okay, let me show you. So here's our circle. So let's copy that. So I want to write a function that export just this single line instead of this a bunch of things. Okay, so let's delete that, save it, close. Okay, so let's go back to the code. So let's start to write it. It will not be easy. So Hike-san, hope you are having a good day. Yeah, thank you. Okay. What's the name? Let's just say export graphics. Okay, so you want to define a function. So what is a function? That inline documentation. So this is how you define inline documentation in Wolfram language. Okay, and so first of all, we need to design this function. What is the argument? So this will be graphics. Okay, so take a graphics and name. Export graphics object G to a file named name. Okay, in SVG format. Okay, G is a graphics object. Okay, and yeah, something like that. Name is a string. In current okay, so that is a usage inline documentation. Okay, now let's write the function. Yeah. Okay, so how do you, so it takes two arguments, so we're gonna use a pattern matching. So there, two argument. The first thing is a graphics. Okay, so what this means, it's taking any argument whose head is graphics, then it will match. This is doing a pattern matching. The second argument must be a string, so file name, let's just say file name. Okay, that means, this means anything, match anything, and name whatever match as file name. Okay, so that, so it will well, first of all, before we write this, it would be nice to output to string. Okay, so write a function that output to string. Okay, that's the first thing. Write a function that just return a string. Then you can later on add a wrapper to export, to write the string to file. Okay, so let's just yeah, let's do this. So it needs to output to string. Okay, so something like that, something God, we need to go faster. So this is gonna be a long video, I think, but no more than, I hope no more than, to complete this, it'll take more than 3 hours, 4, 5, because there's lots of graphics stuff going on, lots of, and coloring and styles. But to create a simple version to demonstrate this works, it'll take like an hour or two. Okay, but I think we're gonna just go do for an hour or 90 minutes, then I'm gonna stop, then I'm gonna code offline. Okay, so back to this. So it needs to return a string. Okay, so graphics to string. So let's rename this. Okay, let's just go all the way. Okay, graphics to strings. String. I mean, let's just make this all the way. Go through the whole coding. Return a string that is a SVG format representing representing graphics object G. Okay, that's the yeah. Okay, so now let's write that graphics to string. Okay, now you don't need file name. Worry about that later. Okay, now return a string. That's it, we done. Okay, so the first thing you have to worry about is what are the SVG like the headers, so this will work. Actually, that may not be valid, so for example, escape quotes. Okay, so this, if you have a SVG as a file, let's look at this. Okay, so you need this. I think you need both of them. Okay, so let's copy that, close. Okay, escape quote. Okay, so you need the SVG XML header, then God, so open that again, then you need to close it. Yes, of course, close. You need to, yeah. Okay, so no, so XML header, then SVG something something, then okay, the view box, those are complicated. Ah, God. So width, height, how should it be? So let's see what's the default width and height. You want the export, so actually writing this is fairly complicated because it gets fairly involved. So what's the default width and height? What should it be? So 1000 pixels by 1000 pixels. Let's say, oh God, this is gonna be complicated. So 100, okay? I mean, let's say 1000, okay? So, and okay, so then view box is the coordinate, customized coordinate. In this case, the same. Okay, then SVG version, well, okay, I don't know. So, okay, so right now, this function is just return a static string. Okay, it haven't done anything with the argument yet. Okay, but it works. So let's try it. Clear, just to make sure. So clear the function, then define the inline documentation, then the function. Okay, and this part, let's just say that. Okay, so let's copy that, paste, run the whole thing. Then let's just say let's say graphics to string. Okay, call it graphics to string. And what is your graphics? The graphics is gonna be, let's just say that. Okay, paste it, shift return. Fantastic. So it just return a string. Okay, later on we're gonna save the string to a file, write to file. Okay, but now we need to actually do something with it, the input. So how do you turn a, so you have this, something like this circle. Oh God, this is gonna be very complicated. So example, okay, so when you have something like that, a circle, you want to turn it into this. Okay, so in this case will be 0, 0. Oh God, no. So this cx and cy, they are the coordinates. So in this case, it's arrangement 0, 0. But here you cannot be 0, 0. So this represents the circle. But here you can be 0, 0 because 0, 0 in the SVG coordinate, they are on the upper left corner. Oh God, this is gonna be a lot more work than I expected. Yeah, to write this, it's gonna be you imagine it'll take 2 hours, but it's more likely it's few days, 30 hours to make it everything. So anyway, so here's a coordinate. You want to turn that into a string like that, and radius 1. Okay, but you got, so oh God, to figure out the whole coordinate is very complicated. Oh shit. Yes, it is. Oh God, I think maybe I'll abandon the project. Sherry says, thank you. What? Okay, so this is this is difficult because so you got a single circle at this coordinate 0, 0, right? But in real life, your graphics is likely to have hundreds or thousands of circles and lines. So you have literally few thousand coordinates. Okay, you have few thousand coordinates. So one of the things you need to do is when you have a graphics, you need to know what's the boundary, like outer bound, the maximum x coordinate, the minimum x coordinate, and the maximum y and minimum y, so that you know how many pixels there are in total, width and height. Okay, that's the first thing you need to know. So for example, graphics may be many other circles or line. Line is represented like that. For example, 0, 0 to let's say 1, 2. Okay, and actually, wait. So that represents the line. Okay, so in real life, you might have thousands of circles and lines and or with different positions. So the whole thing cut. So this may be a real life input. So you need to find the boundary maximum, minimum. Okay, so yeah, to code that is there might be a built-in function to get that. That's one thing. So once you know the maximum, the boundary, the maximum and minimum x and also for y, then you need to scale that to within your SVG width and height output. So your SVG paper is 1000 by 1000 pixels, but you need the internal coordinate to scale whatever is your max to this 1000. So this part view box is your custom coordinate, so you need to scale it there. Then you also need to translate because the Wolfram language, you see the coordinate, the middle is, it's math coordinate, the middle is 0, 0. But in the SVG, 0, 0 is at upper left corner. So then you need to translate. So for example, let me just mark right here. Okay, so this will need to time a scale, x scale, and this part will need to times a y scale. Then you need to translate. So x vector, you need to translate x trans vector. Okay, something like that. Plus, and this will be y trans vector. Okay. Something like that. Okay, so yeah, so let me clear that up. Yeah, something like that. And so very tedious, to do this. You have to think about it, and get it correct. So once we have that, then for each circle, you just turn that into this string. Okay, do you guys see what I'm doing? Simple Postman says, my master degree was partially Oh, my master's degree was partially on mastering complexity. Decide on the expected complete output, dissect it into major parts, and code bottom up to return each part step by step hierarchy. Yeah. So wait, how can I magnify? Okay, so yeah, I think, actually, I think I'm gonna stop. Oh God, because this is gonna be lots of work, boring work. I wish it just would work. Why is Wolfram Language, creating a file that's like 100 times larger? I need this. I really need this because, in my project, I'm gonna need to do. I need to do hundreds of these two-dimensional images. I talked about this. You can check my YouTube. There's lots of hundreds of 2D images. If you create them in SVG, in PNG, the file size is still pretty large, but they are ugly because you cannot scale it. When you scale it up, it becomes ugly. Lines become jagged. Like that. You see. But if it's SVG, then it's perfect. But the problem with SVG, each one of these images is gonna be like half megabytes, so that's not good. Oh God, why didn't Wolfram Language do this correctly? the built-in export. Yeah, okay, so let me think about, do I really want to write this? It's gonna be several days of coding, like 30 hours. So how feasible? Let's see, how can I really quickly code this? No, you cannot do that. So, you are saying that we just take the output and optimize. So you cannot do that because, let me show you. So here's a circle, and let's turn this into XML mode. So you can see it's using a path. Okay, so let me explain this. So let's break the lines. Okay, first of all, a bunch of styles. Then here's the data for the path. Okay, it's all just coordinates. Okay. Okay, so all these are just coordinates. So what it's doing is that it's this capital C that is a cubic Bezier curve. So it's got, it's very complicated. Cubic Bezier curve. So let's go back to circle. It should be just a circle, but it's using the path to emulate circle. So what is the path? So the specification, if you want to do Bezier curve and cubic Bezier curve, is that you use the command C. So where's C? There. Okay. So you see here, to create this curve, the code is this one. So you start M means move to. So move to 0, 0 coordinate, then cubic Bezier curve, then 2 control points, then something, So okay, here's the explanation. So C, every C is followed by 1, 2, 3, 4, 5, 6 numbers. That means 3 coordinates. Okay, two of them are control points. The other one is the coordinate on the curve. So if you have played with Adobe Illustrator or any kind of vector graphics, you can see, you drag the line to control the curve. So that's cubic Bezier curve. That's what this line is, okay, this long line. So what it is doing is it's emulating a circle. Very complicated. So if we want to turn this thing back into a circle, that's not easy, okay? So that's a magnitude more difficult. So this is like involving mathematics, and at best, actually, you can only do a guess, because cubic Bezier curve cannot represent a circle 100%. They are just approximation. So when you actually try to reverse it back to a circle, so find the circle's center and radius, you cannot do it perfectly, I believe. Wait, yeah, actually, maybe, yes, you can. Actually, I think you can. All you have to do is that, so for each C, so let's show it, okay? So for each C, replace C by a new line C, okay? So now you can make it, the structure clear. So that's so it's got 1, 2, 3, 4, 5, 6, 7, 8 cubic Bezier curve. Okay, so the first two, so let's see, 1, 2 number, 3 number, 4 number. The first 4 numbers are control points. So this, the 5th and 6th number, that's the actual coordinates of the curve, on the curve, okay? So for each C, you find the last 2 coordinates. That's a point on the circle, okay? So right now we are trying to reverse this path, emulating a circle back into a circle. So for each of the C, you find the last 2 coordinates, and this one, and this one, this one, this one, this one, this one, this one. All those points are the points on the circle. Then you sum them and average them. Then you get the center of the circle. Then from the center of a circle, you compute the distance to one of these. You get the radius. Okay, so that's how you turn this back into a circle. No, it's not trivial, okay? it's not trivial. So yeah, okay, but now I understand. Okay, so back to this solution. This is more precise solution. We converted by ourselves. But how difficult can it get? So you find the scale, then you find the translation. Another problem is that in SVG, the y coordinate goes down. The lower it is, the more positive it is. But meanwhile, in standard mathematical coordinate, the positive for y is up. So you need to flip it again. So that's a hell, that's usually hell, because it's fairly confusing. So you need to flip the y-axis. God, how do I know? It's very complex because I have tried to work on it before. On some other issue, because I was trying to write plotting software in JavaScript. And I can show you the code. Let's see. So let's go to comp. Let's go to my home directory. So that's my website. So JavaScript, search for draw. So I like 5 years ago, I was gonna write You see? So this is written in JavaScript using SVG and adaptive sampling prototype. The more curved is a curve, there will be more points. Okay, so you can search for JavaScript and you can see the code. So two files. This file is the library. It's actually in TypeScript. 700 lines of code, and the other code is just this. It's still 50 lines of code, 60 lines of code. So it's trying to draw a simple spiral. Yeah, but you can see sine, cosine, they are tangent. So I know. So when you want to plot a curve, sine, cosine, whatever, you want to show it in SVG, you have to do this coordinate translation, and also flip the y-axis. It turns out it's fairly confusing. You spend hours to get it right. Yeah, so let's go back to. So I didn't I didn't go too far with this plotting curves, but there are libraries, like I think there are quite a few. Okay, so what are we doing? So yeah, back here. So this is fairly complicated, man. So we need to do that, and for each graphics we need to turn it into like that, then line similarly, then oh god, this is difficult. So imagine what I need to do. So typically what I need to do is to, for my project, there are hundreds of these, thousands, over a few thousand, over 1,000 of these two-dimensional graphics. So you can see each one of them easily have 1,000 points. So you have to apply translation to this. But then the other difficulty is that then you have colors and styles for each line or circle. You see, so that means to turn that, so that's actually more complex, because in Wolfram language, whenever you have a style, let's say red here, so when you have a style called graphics directive, like red or thickness or line thickness or color, so whenever you have a graphics directive, it applies to the subsequent elements in a list. So we are having a list here. So if you have, let's say, blue here, that means these three circles are red, then the rest here is blue. So each graphics directive applies sequentially until there's another one overriding it. So if this one says thickness, that's another directive. Okay, so this won't override over here because it's absent there. So anyway, the point is that each one affects subsequent style of graphics primitives, but that's not how SVG is done. So for SVG, either you put a style for each of the graphics primitive, like here, or you group them together and say what style it is. So you need a way to convert this sequential kind of ordering into grouped items. So for example, this red circle, 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 you need to turn that into a list by itself. And that's not so easy, because from my example, it looks very simple. But actually, in real life graphics, you might have lots of arbitrary nesting. So you see, you might have arbitrary nesting of graphics. So that gets really complex because you have a tree. At each depth of a tree, the coloring are sequential. Okay, but that's for the same, like brothers and sisters in the same level. The coloring are sequential, but then you got parents and or children. In those cases, of course, the color if the parents specify red, all children should be red, unless one of the children has a older brother that says different color. You see, that's how it's supposed to be, so that's how complex it is. So to properly do the coloring for Wolfram Language graphics, this hierarchy based and sequential based when it's in the same level, you need to turn that into a proper nested hierarchy or have a style for each element. So that's the specification of this problem, and that is not easy. Do you guys see what I'm saying? Yes. So it would mean that you need to cover each shape with a corresponding tag. Yes, that's true. So path is the most general way to represent any shape. So let me get this better. So yeah, we are not gonna code this. It's getting too complicated. God, I hate when this happens. I'm gonna do a live stream. This is trivial. Then it turns out, when you actually do it, it's not so trivial. It's not fucking trivial. So path is the most general way to represent any shape. Yes, and that's why the standard export use it instead of the specific tag. Yes and no. In general, yes, but however, understand that path cannot mathematically represent a circle perfectly. So it's doing approximation, okay? Because it's using cubic Bezier curve to emulate a circle. Okay, that's not good. That's a really kind of a problem, okay? But the rest of the primitives, line, rectangle, or ellipsis, actually I'm not sure about ellipse. I think so, yeah. Ellipse, yeah, you actually, path has a way to represent the ellipse exactly. Wait. If path can represent ellipses exactly, then that also implies it can do for the circle. So, I see. So it actually, path can represent the circle precisely. However, it's not via cubic Bezier curve. You have to use arc. You see. So I spent quite a few months doing this. So here's a JavaScript that shows interactive JavaScript So this thing, so you can see this thing, which is a Lisp major radius, let's say minor radius, and you can also rotate it. Rotation. Let's go to here. Okay, this one is easier to see. So it is possible to use path to represent a circle or ellipse or part of it by the path. Exactly. Okay. So you can see. But however, you must use the command A for arc. Okay, so A is followed by 1, 2, 3, 4, 5, 6, 7, 7 parameters. So you can, so for example, you can represent the circle exactly using path, but not by the Bezier curve. You have to do it by the, okay, this is too large. God. You have to do it by using the arc parameter. Okay. But however, the Wolfram language is not using that. It's using Bezier curve. So it's like one complete fuck up. It's just wrong. It shouldn't do that. Okay. So yes, it is true that path can represent, path is a general, can represent any of the primitives in SVG as far as I know. It can represent, so where is it? Line. It can represent rectangle. It can represent rectangle with corners. It can represent circle, ellipse, polygon, and polyline, and text. Text is font kind of. And cubic spline, yeah, that's path. Okay. Okay, so we learned more about this. So why didn't Wolfram language use the arc? It sucks. Is an SVG file always plain text? Yes. Or is it mixture of plain text and binary? No. It's always plain text. It's actually just XML. So I have the entire tutorial. You can read practical SVGs. It's entirely XML. You can embed bitmapped images in SVG, like a photograph, but the format for that bitmapped image is turned into, I believe, is turned into a ASCII, what's it called? Base 64. I believe it's using base 64 encoding. So in the end, it's still text. Okay. If the programmer who implemented this export algorithm didn't use anything except for path, then it's a lot of digging into. It would mean that you need to cover each shape. Yeah, they have to cover each shape anyway. So what we're gonna do now? So So I have to think about what am I going to do? Do I spend? So to code this fully will take, I would say, 30 hours, okay? To code this, to write a robust version of this export graphics to SVG, it'll take me 30 hours. Is it worth it? So you see, I'm checking out, I'm thinking about, do I want to do this or not? 30 hours. And say 1 day, 1, 2, 3, 4, 5 days. Yeah, something like 30 hours. but I really need it, because if I can get this to, if I did it, then these thousands of images of my Planker projects, they will be very efficient. Beautiful graphics, small file size. Yeah. 30 hours, my God. Okay. I think that's it for today. Thank you guys for watching. Okay, so I think that's it. Am I gonna do it or not? I don't know, but I know for sure I cannot do it like in live stream, because this will be just me coding very complicated stuff. When it's very complicated, live stream doesn't work, because you can't possibly explain the steps what you are doing. And it's very boring to watch. Yeah. Okay, so I have to think about, am I going to code this? Because especially nasty, because when you have, let me show you, when you have nesting graphics, you see, when you need to figure out about this colors thing. Okay, let me think about it again. It's still doable though, so I can definitely do it. So what is the advantage? So if I write this, I can publish it, so other people can use it. That will be, benefit to many people, but usually not too many, because very few people use Wolfram language in the first place. And then they wouldn't know I have written it, because it's hard to find. Yeah, but I gonna use it mostly for myself. I have to think about this. Okay, so that's it. I think that's it. God, this is painful. Wolfram. So is there? Did someone else have? Someone wrote the package. Let's say. Let's search. Okay. SVG exports. Can export graphics directly. Okay. Including region plot and graphics object. The exported SVG file is meshless and retain vector quality. Okay. Allowing for high resolution. Okay. Oh, export string function can also generate an SVG string representation. Fantastic. I didn't know. Export string. Okay, you learned something new. Let's say, is there a documentation? There it is. Okay, basically the same, except that it doesn't write to file. Okay, fantastic. Okay, then XML package provide tools like XML SVG. Oh, graphics to symbolic SVG to convert graphics directly into symbolic XML. which is the foundation of SVG, enabling advanced manipulations such as animation. This capability allows for the creation of interactive SVG, including animations of moving elements. Okay, while exporting to SVG is efficient for vector graphics, large or complex something. For optimal results, especially with plots containing sharp edges, it's recommended to use vector formats. Okay. Yeah, but okay, so why is fuck? So does anyone actually talk about how large file it generates? That's that's really advanced, because vast majority of people, they don't know. They just generate SVG. They don't they don't know the details of SVG, so they don't even know the issue. So let's see, this guy export. Hi, I'm new to Wolfram Language. I would like to export a plot. Okay, this guy is talking about 3D. No, you cannot do that. Okay, I don't think none of this actually dives into detail. None of these actually understand what I'm saying. Because what I'm doing is advanced. Now let's look at this link. So did they explain? Does it explain? No, it doesn't. So can I customize the command? No, I don't think so. Yeah. You see, it turns everything into Bezier curve. Fucking idiotic. Okay. So, question. Do you have any desire to discuss Lisps? Yeah, sure. Whenever I'm doing Emac Lisp, you can kind of ask me about Lisp, usually. Unless I'm, seriously trying to code something. I've read a lot of your articles on this topic, but still can't decide if it's a good idea for me to create my own Lisp that compiles to C. I think you only you know the question, because for the general people, for programmers in general, the answer to that is no, because you are just creating your own language. That's, if you like it, you have your reasons, only you know. If you really love it, you want to do it for a hobby, just for the love of it, whatever, yeah, sure. So, but if you have to ask somebody else, the answer is probably no. Only you can decide it's worth it. So, yeah. That's it. That's all I know. I don't know about writing a compiler. I don't really know about it, so I cannot help. Okay, bye guys.